Hello. Today we're going to talk about radical equations and inequalities. So what does that mean? We're basically solving equations with radicals in them. So what's a radical? Radicals are square roots or cube roots. You can write them in any different way. So if you have right here this square root of x, and you know that it equals 4, we can undo it and get x equals by doing the opposite. Now, what is the opposite of a square root? Well, the opposite of a square root is squaring it. So what we're going to do today is we're going to take both sides of my equation, and I'm going to square the entire sides. So if I square a square root, square of a square root is just that x. 4 squared is 16. And that is your answer. Now, you don't have to worry about negatives because you're squaring it. A negative times a negative is back to positive. So you only get one answer, so don't worry about that. Okay, now you might see this a little bit differently because this right here, this 1/2, also means square root. So we're going to solve this by first treating this like a normal equation. In other words, if I have a plus 9 over here, I'm going to subtract 9 to both sides, minus 9 to both sides, and leave that a to the 1/2 will equal a negative 9. Now, what we're going to do next is we're going to take this entire piece on both sides, and we're going to square the entire side of the equation. So 1/2 squared, or an a to the 1/2 times an a to the 1/2, is just an a to the 1. So what does that equal? It equals positive 9. Negative 9 times a negative 9 is a positive 81. All right, so if I have a equals 81, you can double check your answers to find out, is this really going to work? Because especially when there's negatives, you have to double check them. So if I take this 81 and plug it back in here, is that going to work? Well, remember that this here was a square root, so if I write it as 81 to the 1/2, or square root of that, plus 9, will it end up equaling 0? We know that 81 to the 1/2, the square root of 81, is just a 9, so does 9 plus 9 equal 0? And then you're thinking, yeah, oh wait, no, it doesn't. So that means this is not a solution, and it's called an extraneous solution. And so what we're going to end up saying for this equation is that it is a no solution. So I want you to be aware of that. Sometimes there's no solutions, and you need to double check. If I take this 16 and I put this back up in here, the square root of 16, does it equal 4? Absolutely it does. Yep, 4 equals 4. So double check your answers, because you might do the math right, but you might still end up getting a no solution. Okay, so they might look a little bit bigger, something like this, the square root of 4x plus 1. Now here's what I want you to look at. I want you to look at the size of the radical. Do you notice how all of this is underneath that radical sign? It's all underneath it. That means I have to get rid of that radical first. So I got to take this whole piece, this whole side, and I need to square both sides of that. So if I square both sides, this square and the sign are going to cancel out, leaving me just that 4x plus 1, and it's going to equal a 9. Now, minus 1, and you're left with 4x equals 8. Divide by 2, oops, divide by 4, there we go. Divide by 4, and x equals your 2. Now, double check, does it work? Or are we going to get another extraneous solution? So I'm going to come over here, and I'm going to plug in the square root of 4 times 2 plus 1, and make sure that extends the whole way, equals 3. Does it? I hope so. Let's find out. Inside the square root, it's like having parentheses, so 4 times 2 is 8 plus 1, which we know is 9. And the square root of 9 is 3, so does 3 equal 3? Yes, it does. Okay, this is my solution. I can circle it. That's my answer, not extraneous. So what do we need to know? So here's what we're doing. Step 1, if the index, so remember that's the spot right up here, the number, if there's nothing there, assume it's a 2. The index of the root is even, identify the values of the variable for which the radicand is non-negative. Now that's one other piece. This value underneath here cannot equal 0, or cannot equal a negative value if it's even. If it's a cube, it can be. If it's a cube, it can be negative. But if it's a square or a fourth, it cannot be negative. Okay, so that's important to know. That'll come into play in a little bit. Step 2, we're going to have to solve the inequality algebraically. In step 3, again, test those values, double check your solution. Let's find out if that works. So let's try a little bit bigger problem. So it is a square. X cannot equal a negative 1, so as long as it doesn't do that. Now, notice that this plus 2 is not underneath the radical sign. We got to get rid of that. We got to clear everything outside of that before we do any undoing of a square root. So let's minus 2 to both sides. So these cancel out. We still have the square root of the x plus 1 equals 2. Next, let's grab this whole side, square it, and let's grab that side, square it. Square and square root cancel out. You have x plus 1 equals 4 now. And then let's minus 1. And you notice how nice this just kind of natural follows. So x equals 3. Really? Does it work? Let's find out. Take the 3, put it back into our original equation. Now we have the square root of 3 plus 1 plus 2 equal 4. Yes or no? We'll find out. 3 plus 1 is 4, so I have the square root of 4 plus 2 equals 4. Square root of 4 is 2. Does 2 plus 2 actually equal 4? Yes, it does. Fantastic. That means this is our solution. We're done. We're good to go. Okay, we haven't talked about inequalities yet. So inequalities, what changes? Well, first of all, we're going to treat it like a normal equation. That means this minus 4 is sitting out here. We're going to add 4 to both sides, plus 4 to both sides. We're going to get everything away from that square root. So square root of 2x plus 3 is less than or equal to 9. We're going to now square both sides. Okay, the square and the square root cancel out. That's good. The 2x plus 3 is still there. It stays less than or equal to, oops, I forgot to write the square there. Oh, goodness me. 81. Now let's minus 3 and solve it like normal. Minus 3. We're at 2x is less than or equal to 78. And then divide by 2, divide by 2. And just like all the dividing rules, I'm not dividing by a negative, so the sign does not have to flip or anything. X is going to be less than or equal to, what are we at, 39? There you go. Whew, had to think about that for a minute. Next, notice how x is smaller than 39? That looks like that could go down into the negatives. What if this whole thing was negative? Could I take the square root of a negative? No. So there's got to be a point where values for x will stop working as I go smaller. So I got to do this again, because this square root of 2x plus 3 has to be itself greater than or equal to 0. Now you don't have to worry about the rest of the equation because it's just about this root sign. Now you can square both sides, or you could say, hey, you know what, really what's underneath this 2x plus 3 has to be greater than or equal to 0. Either way you want to solve it is just fine. So minus 3, you get 2x is greater than or equal to negative 3. Divide by 2, and do you notice x is greater than or equal to negative 3 halves? Okay, so x has to be greater than or equal to negative 3 halves, but x also has to be smaller than or equal to 39. I can put these together with this value of x in the middle. X does have to be smaller than or equal to 39, but at the exact same time, it has to be greater than or equal to this negative 3 halves. So this is a compound inequality. It is an and. It has to be in between these two. And that's how we find it. It's about going back to your original equation, looking underneath the square root right up here and saying, that cannot be negative. You can't take the square root of negative and end up with a real number. It just won't work. So that's why we're saying whatever's underneath that square root has to be greater than or equal to 0. Good luck. Let me know if you have questions. Have a great day.